Hello and welcome. This is lecture number 4. Go ahead and write that and today's date at the top of your notes and get ready. Today's lecture is going to be about scientific notation. So pause the video here and go and grab a calculator. You'll definitely need a calculator today. And I want you, as a warm-up, to just compute the following. All right, so let's see. You should have gotten 10 squared. That's an exponent. Hopefully you know how to plug that into your calculator. If you're using your phone as a calculator, try turning it sideways to get that exponent button. 10 to the power of 2 is equal to 100. 10 to the power of 3, you should have gotten 1,000. 10 to the power of 4, 10,000. 10 to the power of 5, 100,000. And then 10 to the power of 6 is 1,000,000. Do you notice a pattern here? Okay, so hopefully the pattern you notice is that the numbers are getting bigger, but in a very specific way. This first one was 10 squared, and it ended up as 100, which is really just a 1 with 2 zeros. So a 2 there leads to 2 zeros. A 3 here leads to 1, 2, 3 zeros, and so on. 10 to the power of 4 gave us 10,000, but that's just a 1 with 1, 2, 3, 4 zeros. And now let's try computing a few more things in our calculators. 2.4 times 100,000 is the first one. Go ahead, try this on your own. All right, so 2.4 times 100,000 should have gotten 240,000. 4.6 times 10,000. This one is going to give us 46,000. 3.3 times 1,000,000. 3,300,000. Do you notice a pattern here? So hopefully the pattern you would have noticed is that when I multiply by a power of 10 like this, I can do a shortcut. Instead of multiplying, I just count the zeros, and that tells me how to move the decimal point. 100,000 has 1, 2, 3, 4, 5 zeros. So I take the number 2.4 and I move the decimal 5 times to the right. 1, 2, 3, 4, 5. And I'm jumping over invisible zeros here that are after that 4, and I can fill them in afterwards to get 240,000. So let's just see if that works with a number like 4.6 times 10,000. So I started with 4.6, and then I have 1, 2, 3, 4 zeros. So it jumps 1, 2, 3, 4 times, and I get 46,000. So hopefully that's the pattern we noticed. Now, can we put together these two patterns to come up with a way to express really large or really small numbers with a common method? So here we have a number times 10 to the power of an exponent. Let's try this just with moving the decimal point. If it's a negative in that exponent, we're going to move to the left. So negative means go left, positive, we're going to move right. So here I've got my number, 6.1. It's a negative, so it's going to go to the left, and it's going to go to the left 4 places. 1, 2, 3, 4. Jumping over invisible zeros on its way to right here. Then I fill in the zeros, and I end up with the number 0.00061 as our number. Now, if you just plugged this whole thing into your calculator, instead of trying to just do it by moving the decimal, you can tell that we do get the same answer here. So at long last, what is scientific notation? Let's write down what it's good for first. It's good for really big / really small numbers. This might feel a little bit like deja vu because we said prefixes in the metric system help us deal with really big / really small numbers. Well, scientific notation is very similar to the metric system, and they can be combined to just help us talk about numbers big and small without having to write out a whole bunch of zeros. So what scientific notation looks like is it's some number m times 10 to the power of n. And our goal is for m to always be between 1 and 10, and then for n to just be an integer, meaning it's basically a whole number, but that includes the negatives, and that'll just tell us how far to move that decimal. So let's practice converting a few very big and very small numbers into scientific notation. And we're going to really try to keep track of the significant figures. Let's start with 65,000 kilometers. So 65,000 kilometers. The decimal point is currently right here. I'm going to keep moving it back until I get a number that's between 1 and 10. If I stop after 65, that's still too big of a number. I always want to just have a single digit at the front, so I'll move it all the way back between the 6 and the 5. So this is 6.5 times 10 to the power of, and then however far we moved that decimal point, that is our exponent. So we moved it 1, 2, 3, 4 times. And then we want to keep the same unit of kilometers. We're not changing the unit here, we're just expressing the number using scientific notation. So, with the prefixes and with scientific notation, we can express numbers in lots of different ways. All right, this next one, we've got a very small number. So this time I move the decimal point to the right. I'm going to move it 1, 2, 3, 4 times before I get a number that's between 1 and 10. So that's going to be 1.23 times 10 to the power of, and how many times did I move it? 1, 2, 3, 4. But I moved it to the right this time, so it's actually going to be a -4. And a good rule of thumb is that really small numbers use negative exponents, really big use positive exponents. And this will keep the same unit of millimeters. Okay. Next one, 0.0200 grams. So again, I'm going to move the decimal point, and I'm going to get 2.00. You have to keep the 00 because they come after our number in the decimal expansion. They have to be significant because we could have just not written these zeros and the number would be the same. If we chose to write the zeros, they must be significant, so they have to exist over here as well. Times 10 to the power of, we moved it 1, 2 times, so 10 to the power of -2. The unit on that is grams. Change this to red. All right, and let's keep going. Now, just for practice, we've got some numbers given in scientific notation, and we're going to convert them back to expanded notation. So 3.4 times 10 to the third. Start with the 3.4, and then the times 10 to the third means move that 0.4 3 times. So 1, 2, 3. Fill in the missing zeros, and I get 3,400 milliliters. Okay, let's try another one. So I've got the number 2.947. It's being multiplied by 10 to the -4th. With a negative there, we're going to move the decimal point to the left, and I'm going to move it 4 times. So 1, 2, 3, 4. And I skipped over some invisible zeros. There they are. Now let's write out the number again with the correct unit. 0.0002947 kilograms. One more, 6 times 10 to the 5th centimeters. So 6.00 times 10 to the 5th. So I should move this decimal point 5 times 1, 2, 3, 4, 5. Jumping over zeros on my way. So I'll add those in, and I get 600,000. So 600,000 centimeters. And now this is kind of a unique case because in the scientific notation, it's very obvious that these zeros here are significant figures. So how do we show that those zeros, which correspond to these zeros, are still significant figures? Well, since we can't use a decimal point, your last resort is just to underline all the way up to the end of the significant figure. So you should underline the 600. Now, I wanted to really briefly talk about another way scientific notation might be expressed. You might see this maybe in a textbook, often on your calculator, sometimes even on your phone. Instead of saying the times 10 to the power of, they replace this part in here with either an E or a small uppercase E. And occasionally, in front of that exponent, you'll see a plus or a minus, just to really emphasize which direction that decimal point is going. So 7.8 times 10 to the 24th, to plug this into your calculator, you actually go 7.8 little capital E 24. So if you see that E, it means times 10 to the power of, especially if it's a lowercase, well, not lowercase, but a small uppercase E. So now I wanted to take a moment and connect this lecture with our previous lecture. Let's convert units, starting with the number in scientific notation and then finishing with the number in scientific notation. So the question is, how many grams are in 8.34 times 10 to the 5th kilograms? Let's just right away convert that 8.34 times 10 to the 5th into just an expanded number. So I'm going to move the decimal place 5 units to the right. So 1, 2, 3, 4, 5. Fill in some zeros. And so now I've gotten rid of that first scientific notation, and I know I'm starting with 834,000 kilograms. And now let's convert that to grams. So in 1 kilogram, there are 1,000 grams. When I multiply these, I'll just add together the zeros and I'll get 834 million grams. I'll show the kilograms cancels out. All right, and there is a way to do this without converting to standard measurement first, and where you just keep it in scientific notation. But we didn't do that, so let's convert this back to scientific notation. The decimal point is currently down here. Let's move it to where we can get this to be a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, 8 spots. So this number here is 8.34 times 10 to the 8th grams. All right, let's try a few more operations with scientific notation. This time, we are not going to expand the numbers. We're going to try to do it with just scientific notation. So what if I'm multiplying two numbers that are given in scientific notation? Well, here's something we can do. 4.4 times 10 to the 4th times 5.6 times 10 to the 3rd. You can multiply just the beginning number part of each of those, and then the tens separately. And so I'm going to do 4.4 times 5.6 times 10 to the 4th times 10 to the 3rd. This is all just being multiplied, so I can use that commutative property of multiplication to rearrange it. Now, what is 4.4 times 5.6? 4.4 times 5.6 is 24.64. And then 10 to the fourth times 10 to the third. When you're multiplying exponents with the same base, you're going to add exponents. So this is now times 10 to the 7th. 4 plus 3 is 7. So 26.64 times 10 to the 7th. But that's not full scientific notation because 24 is not a number between 1 and 10. We need to move the decimal place one more spot, making this 2.464. And then we're going to add 1 to our exponent here to make up for that. So now times 10 to the 8th. 2.464 times 10 to the 8th. And if we were dealing with significant figures, we'd round that to just 2 decimals there. All right, just trying to put a box around that. There we go. All right, now let's divide 2.34 times 10 to the 8th. I'm going to put that on the top of a fraction. And then 5.67 times 10 to the third. I'm going to put that on the bottom. And again, I'm going to separate out the different parts of the operations here. Instead of doing the multiplication first, I will split this and divide these. So I'll do just the 2.34 divided by 5.66. So 2.34 divided by 5.66 gets me 0.413. And then for 10 to the 8th over 10 to the third, we're going to just subtract the exponents. It's sort of the opposite of when we're multiplying and then we add the exponents. We're dividing, so we subtract the exponents. This will now become times 10 to the 5th. 8 minus 3 is 5. Again, we run into a slight problem where this isn't technically scientific notation because this number isn't between 1 and 10. I need to move the decimal point one more to the right. So this is now going to become 4.13 times 10 to the 4th. Since I'm moving it 1 to the right, I subtract 1 from this exponent. All right, and we'll call that good for this lecture video. I'll embed a few more questions for you to practice with here. Other than that, have a good rest of your day.